So let's take a look at determining the concavity of a function and identifying inflection points. So let's say we have to find where f is concave up, concave down, and find its inflection point as well. And we're given the graph of f prime of x, or the derivative, and that equals 4x cubed minus 12x squared. So in order to find its concavity, we basically need to look at its second derivative. And so let me just write down, whenever f double prime of x, or whenever the second derivative is greater than 0, then the graph is concave up. And whenever f double prime of x is less than 0, it is concave down. And if f double prime is equal to 0, then there is no concavity. So it's just when it's positive or when it's negative. An inflection point is when the second derivative changes signs. So it either goes from positive to negative or from negative to positive. So obviously in order to find concavity we have to double derive, but in this case we already have the first derivative, so we only need to derive this once to find the second derivative. So f double prime of x is then going to be equal to 12x squared minus 24x. And what I can actually do is factor out the 12. So I'll factor out 12x. So then we'll get x minus 2. And then what we have to do with the second derivative is set it equal to 0 and find those critical points. We get 0 equals 12x times x minus 2. So I can set 12x equal to 0 and x minus 2 equal to 0. If 12x equals 0, x is 0 over 12, or 0. And if x minus 2 equals 0, then x will be equal to 2. So now I can go ahead and set up the sign chart, just like when we found the increasing, decreasing, and max and min. So one of my points is 0, and the other critical point is 2. And I just need to plug in numbers outside of 0 and 2, or in between, and plug it into the second derivative this time, because we're just looking for the signs, not really for the exact value. So let's say I plug in negative 1. If I plug in a negative 1 to the second derivative, I'll get a negative number times another negative number, which means that it will be positive. So I'll put a plus right there. If I plug in 1, we'll get a positive times a negative. So that'll mean we'll get a negative answer. And then if I plug in, let's say 3, we'll get a positive and another positive. So that means it's a positive. So now that I have recorded my signs, I can now say where f is concave up and concave down and its inflection points. So it is concave up, remember that wherever f double prime is greater than 0 or positive. And so if I put negative infinity there and infinity there, we know that it is concave up from negative infinity to 0 and from 2 to infinity, because that's where the second derivative is positive. So I'm going to say concave up from negative infinity to 0, union 2 to infinity. And there's only one interval where it is concave down, or where the second derivative is negative. And that is from 0 to 2. And in order to find the inflection point is not where the second derivative equals 0, it's where the second derivative changes signs. So the second derivative changes from a positive to a negative sign here at x equals 0. So I can say at x equals 0 and at x equals 2, because it changes from negative to positive.